So for the chapter number 1, an overview of the computer and programming. Okay, so for chapter number 1 is an overview of computer and programming. So objective for this chapter, you will learn about the computer system, simple programming logic, involved in the program development cycle, and pseudocode and flowchart symbol using the sentinel value to end program, programming and user environment, and evolution and program. Okay. One thing about this slide, I forgot to mention is that when you work with the assignment here, when you work with assignment, it's a Python here, right? Python here. So basically for this one, it linked it to the Cengage virtual computer. They already have the Python, right? And you do not have to install anything about the Python. But for any one of you, if you want to work with the Python from the computer, I strongly recommend you install the Python in the computer. Right? And later on, I'll show you how to install the Python in the computer. And in the final project, you have two options. You can work with Raptor, or you work with both Raptor and the Python. And in the case you work with both Raptor and the Python, and give you the bonus point for 30 points for this. Okay, now I go back to this one. Okay, so for this one, the first part of this one is understanding the computer system. I believe that this class is not really focused on the hardware, so I just go with very fast here and do not mention anything about the detail about what is the CPU or what is storage or whatever it is, right? I believe that if you want to go over the hardware, you have ITSC. Right? Any one of you go to the ITSC?
I'm in that class. It looks like it's starting August 23rd.
So computer system is a combination of all the components required to process and store data using the computer. And it has the hardware, it is the physical equipment associated with the computer, and it has the software, the computer instruction that tells the hardware what to do. Right? And in the software, it can be the programming. It can be programming is that when you write the code instruction here, and you have the program instruction written by the programmer. And now we go over to the computer hardware and software. Every computer, you have the 3 major operations. You get input, right? You want to process something, you have to get input, everything. So when you get input, the data item, that the text, number, imaging, image and the sound here. And for the input, you have many ways to get input into the computer, right? You can use a mouse, you can use a keyboard, or anything about this one. You have many ways to get the input into the computer here. So when you have the input, the next thing is processing, right? You get the input, you have the processing here. Processing is everything about the calculation and comparison performed by the central processing unit, about the CPU. It's high of the CPU, and they have the many types of speed with this one. And the output, you see, you got the input, you have the processing. Now it's time to take it out from the output, right? So the output, close this one. How can I disable this one? Yeah, this one. The output, everything about information, you can send it out to the printer, monitor, or storage device after the processing here. And nowadays, cloud is also very common here. You can store it in the Google Drive or OneDrive or Amazon or whatever it is. Now you have the component of computer, the brain of the computer. It is a central processing unit, the CPU, everything about processing here, calculation, algorithm, everything. You do it with the CPU, and also you have internal memory. You have RAM, the random access memory. That means you can write again and again. It's RAM, but remember that when you restart, everything gone, right? And you have the ROM is a read-only memory. Everything about give you instruction for the hardware here. And also we have the mass storage device. It can be the magnetic, optical also, and solid state, and nowadays cloud. You can store it in the cloud, right? And you have the system units and system with it's where you store about the CPU, internal memory, and the most mass storage. And also you have the input device, you have the keyboard, mouse, and so on. And this one also, right? And the output device, you can have the monitor and printer. Again, this class is not focused on the hardware of the computer, so I do not go into detail on that one, but it's very general information, and I know that you know what is a CPU and so on. And central processing unit, it is called the brain of the computer. It receives the program instruction, do everything with the calculation, logic operation, and perform the arithmetic operation here. And also it controls as a computer component, right? And it consists of millions of transistors on a single microchip that plug into the motherboard. And the speed of the CPU is measured at a gigahertz here. You can see, you often hear that it is a 3 gigahertz or 3.5 gigahertz and so on. Gigahertz, you can think about it. Gigahertz is one oscillation here, and you can do one calculation or processing. And the ROM is a read-only memory that is it contains instruction used by the computer during startup. When you power up, boot up the computer, it takes the instruction from the ROM and give instruction to the keyboard, to the mouse, and whatever it is. And for the RAM, it is random access memory. It's a scratch pad used for during the work, and it can be read or written too. And RAM is measured in the megabyte or gigabyte. Okay, so you have the basic unit of memory. So the basic one is a bit. Bit that means 0 and 1, right? It's 0 and 1 because everything in the computer is processing with binary system. And later on in this class, we learn about the binary system and so on. Binary system that we all have 2, 0 and 1, right? You can think about you have the switch here. When you switch it off, you have number 0, and when you switch it on, you have number 1 here. And you have 1 byte. 1 byte, it has the 8 bits here. And also it can have the kilobyte, megabyte, and gigabyte, and so on here. And remember that you have the kilobyte, it's not exactly 1000 bytes, but it's 2 raised to the power of 10. We have the 2 raised to the power of 10, it's 1025 bytes. It's the same with the megabyte. The megabyte is that means 1024 kilobytes, not exactly 1000. And for the mass storage device, you have the HDD. It's very common with the HDD, right? It's a magnetic storage. And nowadays you can work with a solid state drive storage here. It works very fast with a flash drive here. And also we can store it in the optical storage in the CD or DVD. And now again, remember that nowadays the cloud computing is very, very common. You can store it in the cloud and you can access it from anywhere. It's acceptable, providing that you have internet access. And for the cloud computer, break it down in the infrastructure as a software, platform as a software, and the software as a software. A service. Now we talk about the input and output device. Input, you see, you can have the keyboard, everything you need information into the computer. You have the keyboard, you have the mouse, you have the digital pen, and modem or wireless internet connection, touch screen, joystick, voice command, and more. Input everything. You give information into the computer, right? So when you got information, you do everything with the processing, and the computer it take it out from the computer is the output here. Output, it can be monitor, printer, speaker, or modem or wireless internet connection. Now, every computer you have the hardware and the software, right? The software, again, for the software, break it down into two major categories. The first one is application software. It have to enhance the product creativity, solve the problem, supply information, provide entertainment. So we can think about the Microsoft Word, Excel, database, spreadsheet, and photo editor. They are the application software. Right? And the second one is the system software, and sometimes we can think about the operating system or the firmware here. That is everything about the control and maintain the hardware. Think about the Windows, right? That you need Windows in order to control and maintain the hardware and support interface with the end user and interface with the application software here. And communicate with the user. It is a function of the operating system here. Manage and communicate with application. And you can think about the Windows, Linux, Unix, and DOS. They are system software. They are operating systems. Now, for the software, when you want to write program, right? You have again break it down into the two major categories. The first one is a machine language. The second one is a high-level language here. Now we talk about the machine language. Machine language, it is a low-level language. That means it directly interfaces with every hardware in your computer. It's a hardware in your computer, right? So it's a machine language. It consists of the sequence of 0 and 1 because underlying of every computer, it works only with 0 and 1. You know that, right? So in the machine language, it consists of the sequence of 0 and 1. You can see. But when you look at 0 and 1, you have no idea what is it and what the function is, right? And when you work with the low-level language here, you have totally mastered in your hardware. You know what is it, and you have to, and it is specific, hardware specific. That means when you develop the low-level language with the machine language here, it might work with the computer, but it not work with other computer because it is hardware specific, right? Okay, and you have to really understand about the structure, about the command of the hardware here. So for the machine language, it's very hard for you to understand. Then they develop with assembly language a little bit higher for you, easy for you to understand. It's a symbolic representation of the machine language. It can be, you can have example A and B here. And back then, when you learn about assembly language, it's quite hard for you to understand. Yeah, it's still hard, but it's way better when you compare with the machine language. Now, the second one is the high-level language. It contains English words and phrase and anti-product expression, and easier for you to understand, to learn and use. And programs are easier to read and modify. And some of the examples of the high-level language, you have the C++, JavaScript, Java, Visual Basic, and so on here. Now, I think I have to go here to explain what is
A program is a set of instructions that tells a computer what to do in order to come up with a solution to a particular problem. A program is a set of instructions that tells a computer what to do in order to come up with a solution to a particular problem. Programs are written using a programming language. A programming language is a formal language designed to communicate instructions to a computer. There are two major types of programming languages: low-level languages and high-level languages. Low-level languages are referred to as low because they are very close to how different hardware elements of a computer actually communicate with each other. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration. There are two categories of low-level languages: machine language and assembly language. Machine language, or machine code, is the only language that is directly understood by the computer, and it does not need to be translated. All instructions use binary notation and are written as a string of ones and zeros. A program instruction in machine language may look something like this. Technically speaking, this is the only language computer hardware understands. However, binary notation is very difficult for humans to understand. This is where assembly languages come in. An assembly language is the first step to improve programming structure and make machine language more readable by humans. An assembly language consists of a set of symbols and letters. A translator is required to translate the assembly language to machine language. This translator program is called the assembler. It can be called the second generation language since it no longer uses ones and zeros to write instructions, but terms like move, add, sub, and end. Many of the earliest computer programs were written in assembly languages. Most programmers today don't use assembly languages very often, but they are still used for applications like operating systems of electronic devices and technical applications, which use very precise timing or optimization of computer resources. While easier than machine code, assembly languages are still pretty difficult to understand. This is why high-level languages have been developed. A high-level language is a programming language that uses English and mathematical symbols, like plus, minus, percent, and many others, in its instructions. When using the term programming languages, most people are actually referring to high-level languages. High-level languages are the languages most often used by programmers to write programs. Examples of high-level languages are C++, Fortran, Java, and Python. To get a flavor of what a high-level language actually looks like, consider an ATM machine where someone wants to make a withdrawal of $100. This amount needs to be compared to the account balance to make sure there are enough funds. The instruction in a high-level computer language would look something like this. X equals 100. If balance less than X, print insufficient balance, else, print please take your money. This is not exactly how real people communicate, but it is much easier to follow than a series of ones and zeros in binary code. There are a number of advantages to high-level languages. The first advantage is that high-level languages are much closer to the logic of a human language. A high-level language uses a set of rules that dictate how words and symbols can be put together to form a program. Learning a high-level language is not unlike learning another human language. You need to learn vocabulary and grammar so you can make sentences. To learn a programming language, you need to learn commands, syntax, and logic, which correspond closely to vocabulary and grammar. The second advantage is that the code of most high-level languages is portable, and the same code can run on different hardware. Both machine code and assembly languages are hardware-specific and not portable. This means that the machine code used to run a program on one specific computer needs to be modified to run on another computer. Portable code in a high-level language can run on multiple computer systems without modification. However, modifications to code in high-level languages may be necessary because of the operating system. For example, programs written for Windows typically don't run on a Mac. A high-level language cannot be understood directly by a computer, and it needs to be translated into machine code. There are two ways to do this, and they are related to how the program is executed. A high-level language can be compiled or interpreted. A compiler is a computer program that translates a program written in a high-level language to the machine language of a computer. The high-level program is referred to as the source code. A typical computer program processes some type of input data to produce output data. The compiler is used to translate source code into machine code or compiled code. This does not yet use any of the input data. When the compiled code is executed, referred to as running the program processes the input data to produce the desired output. When using a compiler, the entire source code needs to be compiled before the program can be executed. The resulting machine code is typically a compiled file, such as a file with an exe extension. Once you have a compiled file, you can run the program over and over again without having to compile it again. If you have multiple inputs that require processing, you run the compiled code as many times as needed. An interpreter is a computer program that simulates a computer that understands a high-level language. This means that the interpreter translates the source code line by line during execution. Consider again a computer program that processes some type of input data to produce output data. The interpreter executes the code line by line, which results in the desired output data. The only result is the output data. There is no compiled code. When using an interpreter, every time you want to run the program, you need to interpret the code again, line by line. There is no compiled code to use if you have multiple inputs that require processing. To understand the difference between compiling and interpreting, let's examine the equivalent in human languages. For example, consider a movie made in Asia where all the characters speak Vietnamese. To market the movie to an international audience, the spoken text needs to be translated into English. A translator would sit down and carefully translate all the text and create subtitles for the movie. Anytime someone wants to watch the movie, they can turn on the subtitles. This type of translation is the equivalent of compiling. Everything is translated once and can be used many times afterwards. Now consider a delegate from Vietnam giving a speech in the United Nations in Vietnamese. In order for the attendees to understand the speech, there are a number of translators who provide a translation that is transmitted to the attendees' headphones. This translation occurs close to real time. Every time the delegate speaks in Vietnamese, the translators get to work. This type of translation is the equivalent of interpreting. Text is translated line by line as necessary, and the results are not used again. Compiled code tends to be faster since the translation is completed in one step prior to the actual execution. Interpreted code, on the other hand, is more flexible and can be run interactively. For example, using interpreted code, you can try out a few lines of code to see if they work very quickly without having to go through the steps of compiling and executing the program. One advantage of using compiled code is that it does not reveal the original source code. This makes it possible to distribute a program without revealing its inner workings. When you install a software application on your computer, you are typically installing a compiled version of the code. You can run the software application, but you can't open up the source code in the original programming language. For many companies selling software applications, the original source code is a well-kept secret and gives them their competitive advantage over other companies. Examples of compiled languages include C and its derivatives, C++, and C#, COBOL, and Fortran. Examples of interpreted languages are Java, Perl, Python, and Ruby. There are two major types of programming languages: low-level languages and high-level languages.
Okay. So we know what is a low-level programming, and what is a high-level programming, and what's a compiler, and what's the interpreter. Right? Now go over this. What do you think? What are pros and cons of low-level language? Tell me. What do you think about the low-level language? What are the pros and cons?
Can't read it. Only
Yes.
the computer can read it.
Mhm.
So that'd be a con, I guess.
Mm-hmm. What is the pro? What do you think? What is the pro? As a con, you see, it is very hard for you to understand it, right? Very hard for you to modify it, and it is hardware specific. It might work with your computer, not work with the other computer, right?
It might also be a pro. Like if you're a company that doesn't want their code to be read, when it's like that, no one else can read it, so it's almost hidden, right?
Okay, right.
So that could also be a pro.
Okay, and that's one thing about the project. What do you think about pro? It is the pro here is that work very fast, right? Because the thing you do not have the translate into the machine, into the machine language here, right? It work directly with the hardware because the computer understand everything about 0 and 1, and when you code it everything with the low-level language 0 and 1, you do not have to translate, right? That's why it works very fast. That's why you see some of the operating systems they still work with the assembly. It works very fast. Okay, now think about the high-level language. What is the pro and cons of the high level? What do you say?
We can read and write it.
Yeah, very easy to understand, very easy to modify, to program it, right? Yes. And it's a portable. That means it works with a multiple computer here, right? Not hardware specific. Okay, what about the con? Sorry, yes, the con. Yes.
Much slower.
Yes, because you have to translate it into the machine language, right? Because underlying every computer, it works with the machine language. Right? You have to translate it. It's slower, and also it consumes storage memory, right? Because you have to buffer to storage. Okay. And also we learned about the compiler and interpreter. Tell me when you use the compiler and one is user interpreter. And what is the benefits of the, what is it?
Compiler to keep running the program, kind of like an old.
Yes, compiler user compile one time, but it can execute multiple times later, right? Only do it one time and execute it multiple times. But interpreter, you have to do it one line by line. You have to do it. So you have more flexibility with this one, right? So we have the short code or automation program, very short, but you see, indirectly see what is going on. Right? So it's up to your application. If you have the long code and you need to for sure you want to run it again and again at the same time, you work with the compiler. But you have the automation, you have the short code, and you want to have more interaction. You have to work with them. Now, we move to the understanding this simple logic program. Program with the syntax error cannot execute it. So we learn about the logical error and the syntax error here. Now, the first thing about the syntax error, I will give you some examples of the syntax error. I'm not sure that. We have the, let's see, I have some of it. Okay, so here is a very simple program I taught. So for this one, again, for every program. Again, remember that every program you have the three major components, right? You have input. I don't know why I'm not able to write. Right here, yeah, it's okay. So basically, you know that for every program, you have the three major components. You have input, right? You have input here. You have processing. And when you're done with processing, you take it out the output. That is three major components of every program. And for this program, it's very simple. For this program, it's very simple here. The input here, I got the input here that I got from user. That is a number, right? I get it. I get my number here. That is the input here. My number, the input. Processing for every number, I just double it. Right? That's why I have my number is my number 2 here. I just double it here. And the output, I just take it out. What is my number? Double, and I print it out. Right? So that is very simple program here. You can see I got the my number. It is later on we learn about variable here, and I got it from end user. I store it into the variable my number here. And you know again, you know that my number, it is a variable. So what is variable? Variable, that means changeable, right? So one time you can get it from user number 5, but later on you can get it from the number 10 or whatever it is. So variable is a changeable. And remember that for every variable, when you got it, it has specific slot in the memory. So we see when you got it from the end user, you store it in the my number here. Actually, you got it slotted from the memory. And remember that variable is a changeable. One time it can be number 5, and later on it can be 10, and so on. So this program is very simple program, and you can see how I run it here. When I run it, it's very simple program. That's why you see. I got it from end user, right? I got it from end user here. Now enter the number. If I enter the number 5, it doubles my number and print out my number here. Is number 10. Right? And later on, if I run it again, I have the number 10, and it prints out number 10. Right? So we see. The thing I want to mention about this one here is the first thing I want you to understand about the definition of the variable. Variable is interchangeable, right? And you can get it from end user, and it only reserves one slot here. It only reserves one slot in the memory. And the name of the slot here, you store it into the my number. It is my number here. So when you get it from user, right? If user enter number 5, it's stored in the number 5, right? That is the process you get it from the end user. Now the second one is my user equal to the my user number times 2, right? So we see that is the old one here. The new one is my number here, my number. The new one, it is a 1. So what's it? Whenever you call to my number, it reference to the slot in the memory. It's the name of my number, right? You take it out number 5 and it time it to 2. So the new one is number 10. And again, it will override this one with number 10 here, right? And take it out, it print out my number. So this is very, very simple program here. Now let me show you something. We have definition about the logical error and the syntax error here. Yeah. Now we're talking about the logical error and the syntax error there, right? So the first thing about the syntax error. So whenever you got the syntax error program to stop it and not able to execute it, right? So think about this one here. Now I just modify my program. I just modify my program. So think about this one. I have my number. I have this number S here. Now see in the Visual Studio Code is very helpful for you. Even that before you execute, you see something going wrong, right? Something going wrong with the code here. So we see when I execute it here. When I execute it, enter number 10, number 5 here. Sorry. And I got the syntax error. Right? Syntax error, well, remember, whenever I have the syntax error, program will stop it. It's not able to execute it until you have to find out and fix it. Right? And the reason is not it has a syntax error here because here when the program, think about this one here. When you run program, think about this one, you enter the number 5 here, right? You enter the number 5 here, and remember that is stored into the variable name my number here. And you put the number 5 here, right? Now the second one, the my number, sorry, my answer, not my number. So my answer here, actually when you have the my answer, again, it takes another slot in the memory with the name is my answer here. Now we take it out. My number. Why is it? It's not able to find. Right? Because see, the name of the variable here is not the same. It's not the same, right? So it try to locate where's my number X here. My number X here. But they are not able to find anywhere in the memory. That's why you got the syntax error here, right? You got the syntax error here. So remember that when you have the syntax error program, you stop it. And you are the one who have to find out and you have to fix it here. You have it run smoothly, right? So that is a syntax error. Again, this one is syntax error here. So I know for sure here, you see, it tells me my number is not defined because you see, it's not able to see anything in the memory with the name my number S here, right? That's why you have the syntax error. So again, in order to fix it, it's very simple with this one. You just change it back to the my number over here. My number over here. Right? And you can run it again. Now it works again. Right? It's work again. Okay, so that is a syntax error. Remember that syntax error, whenever you have the syntax error, program will stop it. And you are the one you have to find it out and you have to fix it. to have it run again, right? Now that is syntax error. The second one is a logical error. So with a logical error, it will run it smoothly with the program. Run it, but the output is not what you expected. Now think about this one here. I expect that when I have to enter the number here, I enter the number 10, right? And I expect that when I double it, I have number 20 here. That's the correct output, right? But somehow in the program, I make mistake here. Instead of double it, I plug in number 2. I plug in number 2 here. Now see what happened here. I run it. Program run it smoothly, right? I have no error with this one here. Now you see when I run it here, I enter the number 10. Right? I expect that when I double it, it is a number 20. Right? But with this program here, I have number 12. So you see, even that it runs smoothly, but the output is not what I expected here. So that is logical error. Right? So remember that when you have the logical error, the program runs execute smoothly, but the output is not what he expected here. Make sense? Okay, and the way you can find out the logical error is about that 10 scenario here. So think about whenever I enter number 10, I expect number 20, but why number 12 here? I have to find out. Right? I have to look it out in the code here to see what is going wrong with my program. Right? So basically, you have two major category error here. The first one is it is a syntax error. Remember, syntax error when you execute program stop it, and you are the one who have to find out what is it and have to fix it. Right? The second one is a logical error. Logical error program run it mostly, but the output is not what you expected. Make sense? Okay. The same you can do with the same. I think you can do the same with the router here. You can do the router. You guys can open the router, and I want you to play around a little bit with the router here. Okay, then open the router and make sure you are able to run the router. You will come back with the router later when you work with some hand-on activity. Now, so you know about the logical error and the syntax error, right? So what another thing I want to mention about the variable, I mentioned it already, right? So variable, remember that variable is a name memory location. Name memory location. Now think about this one here. You have the number, and you have number. They are not the same. They are not the same. See, you have the number and you have the number S here. They are not the same, right? And remember that every variable they are attached to the slot in the memory and with the name memory location here, right? So think about I got the number 5 here, but later on I can have number 10 and number 15 and whatever they are. It's changeable. But the new one, when you want the new one, it will override the override. Right? So think about this one here. Let me show you example. If I have my program here, I have my number here. My number. I put it number 10. Right? I put it number 10. Now I have my number. I put it number 20 here. And I have the new number. Now I assign it to my number. Plus my number. So what do you think? What is the value of the new number? What do you think about this program? Yeah.
30.
What do you think? 30. Any other answer? I have my number 10, my number 20, and new number equal to my number plus my number. What do you think? What is the value of the new number? He gave the 30.
40.
Yes, 40 is correct. The thing here is, you see, I have, for this one, I have variable name my number, right? I have variable name my number. Now, the first time I assign it is the number 10. Huh? Now I have a number 10. The second time I assign it number 20. Remember, when you have the number 20, you can override this one. Override this one. So now it changes to the number 20, not 10 anymore. So see, I have new number equal to my number. What is it? My number here reference to the slot with the name my number in the memory, and take it out number 20. Now put it out number 20 here. Again, this one reference to the slot in the memory with the name my number, and take it out number 20. So see, 20, 20, you have a 40. Make sense? Okay, so just want to make sure you understand about the logic of the variable here. The first thing, it is changeable. It's changeable, right? Changeable, and whenever I got the new value, it will override the override, right? Okay, and everyone has specific name for this one. Specific names for this one. You see, if you put number at here, it's not the same with the my number. Everyone has a specific name. Okay, now we learn about the syntax error, logical error, about variable. Now we mentioned about we talk about the understanding the programming development cycle here. Programming development cycle, you have the sum of the major phase here. The first one, you have to understand the problem. You have to plan the logic, you have to code the program, you have to use the software, can be the compiler or interpreter, to translate program into the machine language. You have to test program, you have to put program into the production, and you have to maintain program. So basically, you see, for every program, normally you have to go all over to the major phase here, understand program, plan the logic, and so on. Now, think about this one here. Think about, I give you the example here. News site, right? Okay, the thing about this one, you can think about programming. It is the same with the daily activity you do, right? So think about my wife. She really like cookies, and she tell me that, can you please make some cookie for me, right? So I think that is very easy. I can do it. I can do it. So I buy a flour, I buy milk, and I mix it up with the eggs, and I put it in the oven, and I take it out and give it to her. Now you can think about the process for programming quite for the same with the daily activity when I make some cookie here. But you see, when she tell me make me some cookies, what do you think? What do you think about my activity here? I said rush it to the broker, take out some egg, flour, milk, mix it up, put in the oven, and take it out. What's wrong with my activity? What is it? Any comment?
Gotta plan it out.
Yeah, you have to plan it out, right? The first thing is very important in every program here. You have to understand the program. You have to be very specific about the requirement, right? She asked me, please make me some cookies. Now you have to specify how many cookies, right? You want it crunchy, or you want it soft, you want the chocolate chip, is that or not? How big it is, how many, right? You have to very specify what is the requirement here. The same program, right? Same program here. The first step is very important that you have to understand the program here. What is the requirement? So basically, for the requirement here, it's very simple here. It's actually not very simple. The first step to understand program, you have to understand about the output. You have to understand about the requirement. Right? So think about my example here. I have to go back to the requirement from my wife. She wants 5 cookies She want crunchy. She want big, how big it is, right? And she want the chocolate chip. So I have to very specify about this one. Right? How crunchy it is, how many chocolate chip here, right? So the same program here. If you rush it into the program without deeply understand program, later on you have to go back and fix it. Many times you have to fix it. That's why I have put a lot of effort in fixing it here. And you can think about the customer here. They have a lot of requirements, and you have to specify specific is the requirement from the customer. Right? Make sense? So it's very important step. The first step you think about, you have to deeply understand about the problem, about the requirement, about the output. Now, so think about once you understand about the output, about the requirement, you can come back to the input. Oh, from the 5 cookies, how many flour I need, how many milk I need, right? And how many eggs. So basically, from understand problem, the first thing you have to understand about the output, about the requirement. So we can go back to see program here, right? So we think about this one. I want to write program to figure it out. What is the area of the rectangle? Right? I want to figure out what is the area of the rectangle here. Now tell me, for this program, what is the output? What's the expected output here? I want to figure it out. What is the area of a rectangle? So what do you think? What is the expected output? Area. Huh? That's me to write program to figure out what's the area here. So I want to find out what is area. That is the output. That is the output here. So basically, to understand program, the first thing you have to understand about the output, I need to figure out the area of the rectangle. Now, from the output, I want to find out area of rectangle. What do I need in order to find out what is area? What do I need? What do you think?
Like times what?
Yes, exactly. That they are input. So see, from the output, you can come back to see what you need to get the input here. Right? So we see you need the length, and you need the width here. Okay, so when you got the input and the output, when you got the input, you do it with the processing. You do the processing, so you can, in the time you apply the algorithm here, later on, mention about the algorithm of calculation formula here. Right? So basically, the same when you come back to the program development here, when you come back to program. This one. Okay, when you come back to this one, the first very important step you have to do is you have to understand program. You have to specify what's the requirement, what's the expected output. Make sense? Now you see, when you have understand the problem here, the next one you have to plan the logic. Plan the logic. I understand that she want 5 cookie crunchy, right? Chocolate chip. So see, I make plan. How many? See, I make a plan here. I specify here how many milk, flour, right? Flour here, milk, and so on here. Right? Now, code program. Actually, code program is very simple. It is very simple step here. If you understand the logic of program, code program that you just translate it into the programming language. You understand the logic, you just apply it and translate it. It might be that different between the Java or Python or so on, but once you understand the logic, you can apply it into the programming. Right? So you see, if you use a software, compiler, or interpreter, it's up to you. Now, that also very important. Right? When you're done with the cookie, I have to test to make sure it's crunchy and it's not overcooked. Right? And so on. And if something going wrong, I have to come back to see what's wrong with my program. That's why they call it a cycle. Cycle, that means anytime you find something wrong, you can come back to find out what's going wrong with the program and fix it. Okay, makes sense? And for the large program, you can put it into production, and you also have to maintain program with the customer and to see what do you need to maintain the program. So see, again, this is a cycle. This is a cycle. At any step, if something go wrong, you can come back to fix it. So understand program. Same. You have to understand what is the requirement, what's the output here, what's the expected output here, right? Plan the logic, write the code, translate into the code, test program, put program into production, and maintain the program. Make sense? Okay. Yeah, understanding problem is one of the, you can see that one of the most difficult aspect of program. You have to put a lot of time, put a lot of effort in understanding requirement and output here, right? And for user, or you can be the end user here, is a people from whom program is written, right? And also some program you have the documentation, you can have about the instruction, right? For the help, what you expect to do with the program. Okay, I think what time is it? Okay, take a short break and come back in 5 minutes. Okay, so as I mentioned earlier, for this class, the first thing you have the software, right? The first thing you have to download is Interrupter. When you work with the Python, it's optional. Python is optional because mostly in some of the assignment, it links it to the SendGate, and you work it from virtual computer in the SendGate, and they will have the Python here. But for some of you, if you want to really to work with the Python, and here's something you can do it with the Python here, right? The first thing you have to download and Python is this one here. You can see where this one. This one you have made release here, and you can take anyone from them, right? You can take anyone from them, right? So when you download the Python, you can okay, so Python here. So for the Python, when you install the Python, you have the idle here, interactive mode here, right? So in the interactive mode, that is where everything you work with the Python in the interactive mode. Everything what I have I equal to 10, right? So I have I plus 2, sorry, I plus 2, I have the 12 here, right? And I equal to 5, so I have I here, I have the 50 here, and so on, right? Everything in the interactive mode. Whenever you do it, you can see it instantly here. That is, you can think about interpreter here, right? Interactive mode. Or with the Python, you can work with the compiling mode here. Here. When you work the compiling mode, you can work with new file here, right? So you can get it right? Or to the input and the number. Right, school out. What is the so we can save it. You can save. You can save. You see, when you save it, make sure you save it to the Python file here, right? And you can put it into desktop here. And you can put that here to desktop. So see, when I save it, I can open it here. I can open, locate it in the Python desktop. I have that here, and see that when I run with the compiling mode, right? I run it here. I run it run the mode here, and there's another and down right. So it is a compiling mode. So basically, with the Python here, you have two options. You can work with the interactive mode or the compiling mode. It's up to you. But I do not like to work with the idle from the Python here. I want to run with the Visual Studio Code because it have more tool for me to check with what's going on with my code here. That's why see you can download the code Visual Studio. Click on this one to download the code Visual Studio, and you download it for Windows. So when it works in Windows, I come back to this one here. Come back to this window. So make sure when you download it, the first thing you have to go with extension. Where the extension? extension, right? So when you download it, you have to go with extension and you put the file. Because the Visual Studio Code, it can work with whatever programming language. It can work with Java, Python, and C++. You have it support many programming languages, right? But if you want to work specifically with the Python, make sure you download the extension here. You click the Python and you install it. I already installed it here, that's why I only have the option for disable or install here. But if you are not, you have to make sure we go to the extension and you download and install the Python into your program, into the Visual Code here. And if you want to know more about how to run the Python in Visual Studio Code, I have a slide here, right? So when you remember that, when you go to the slide, I mentioned it. I will put it in the module, right? In the module. You go to the learning activity, and I had the module number 1 slide here. And in the slide, I mentioned I had one slide mentioned how to run it with the Python idle and how to run it with the Visual Studio Code here. And if you want, you can do it, but it's optional. Again, it's optional for this class, right? You can merge the assignment. You work with the virtual computer in the second. You do not have to work with Python here. But if you really want to work with the Python and if you want to work with the project with the Python, you are feel free to do it with the Python. Now I come back to the slides. The first one, understand the problem, right? The second thing here is the planning the logic. Also, this is very important step, right? You have to very specify about the planning and what step you have to do in your program here. It is class step of program and what they include. And normally in the complex program, you have to include the algorithm. Algorithm is a sequence of steps or rule that you have to follow to solve problem, right? And the most common planning tool is a flow chart or the pseudocode. Later on, I explain what is a flow chart and what is pseudocode here. And again, for planning tool logic here, you normally for complicated program, you have the dash checking. Dash checking, that means you have step by step to check if program delivers the expected output or not. I think about this one here. When I get to enter the number, I double it. When I enter the number 10, I double it. I expect my number is 20 here. But for some reason, it brings down number 12, right? That's why I have to put it some dash checking here to make sure it delivers the expected output. Okay, coding program. Actually, it's not hard. It's not complicated if you understand the logic. If you understand the logic, you can apply the logic into the specific programming language. Yeah, it can work in the Java or Python or whatever it is. Right? So you have 100 of programming language available, and it's choose based on the feature. And each of them they have specific feature. They have a pro and cons, and it's up to you. Right? And basically, they are quite similar in their basic capability. They're quite similar. And once you understand the logic, you can apply it into the specific programming logic here. Coding is easier than planning step. Coding easier than understanding the problem. And the two major important steps you have to do is understand the problem and planning the logic. But the coding is quite simple. And experienced programmer can successfully combine the logic, planning, and programming coding in the one step here. Now we talk about using the software to translate program into the machine language. You can have the translator program. It can be the compiler or interpreter. I show you already, right? And chain programming you can lie the high-level programming language into the low-level machine language, because whenever you go with the high level, ultimately you have to translate it into the machine language, because the machine language is the only language computer understanding. Everything about 0 and 1. Also, mention again about the syntax error. I know that syntax error is something that stop program and you have to find out and fix it. Okay, so that's you write the code program, compiling program, and if everything. Now, when you compiling program, it show you if something wrong with the syntax error or not, right? If syntax error, you have to go with again, check it again, and fix it again, and compile it again. So when you're done with compiling, you have the executable program here. You can type exe program, right? And you can run it multiple times again and again, and every time you get data from the user, and it delivers output into you. Okay, for the testing program, pay attention to the logical error. It's very important here, right? Because when you run it, you see it run it smoothly. Oh, my program is work perfectly, but the output is not what you expected. Right? So make sure you have to pay attention in the testing. Make sure that the output is what you expected here. And again, for every program, make sure that when you run it, you have to testing scenario. You have to do it again and again here. Okay, now when you test program, you have to process a debugging exercise. Sorry, debugging here. Debugging, and in your class, you for each week you have the debugging exercise assignment. And they expect you that you have to find out what is a logical error, what is a syntax error, and you have to find out and you have to fix it. Right? Okay, debugging is the process of finding and correcting program error. And the same with I show you here. And the same way I show you. If I somehow change my program, somehow I change my program here. If I change it to number 2 here, I have to, when I run it, I have to find out what is wrong here, and I have to fix it here. And one thing I can see, one thing I can show you, one thing I prefer about the Visual Studio Code here, even that before I execute program, even that before I compiling program, it already show me something wrong here. Right? So it's very helpful with the Visual Studio Code that I see something wrong, and because the variable here is inconsistent, so I can change it. Right? And you see, if I copy the same, I paste into the and my account I close it. I don't get it. I don't. Here. Anymore, I put it here. It not show me. It not show me the error with the idle integrated from the Python. That's why I prefer Visual Studio Code more than this one. Right? You can see that when I work with a Visual Studio Code here, when I put the number, I put something wrong in here, it shows me something wrong. Right? Show me something wrong. Yeah. Okay, that's one thing I want to show you. Now come back to the slide. So debugging is debugging is the process of finding and correcting program error. And remember that it can be the syntax error and the logical error, right? And you expect that for any program, it should be tested with many steps data, not only once. I think about the number. What happened if I enter the negative number? What happened if I put the floating number, and so on? Right? So we have to, for one program, you have the multiple testing scenario here, only one, not only one. Okay, and the putting program into production is a process depend on program purpose. Like might take several months conversion. Maintain program also. If you have anything you need to update or change, you think about the window also. You can manage patches for window, right? Okay, remember this is a development cycle. That's why you can go back to change it anytime at this process. Do it again and again, iteration. Now, about the planning, right? The first one, understand problem. The second one is understanding the logic. Making plan here. So basically, in the making plan, you have the two way. Normally, you have two ways to do it. The first one is pseudocode. The second one is a flowchart. So what is pseudocode? Pseudocode is English like representation of logical step. It takes to solve the problem. So remember, pseudocode is not real programming language. It's not real programming. That is everything about the logic. But once you understand the pseudocode about the logic here, you can apply it into the specific programming language. Right? Okay. The second one is flowchart. Flowchart is pictorial representation of the logical step take to solve problem. and later on you can see that is example of the pseudocode. That is an example of pseudocode. So what happened here? Pseudocode, you can see with the pseudocode, it's a very simple program here. It's a program here, right? So we see with this one, you have start, you have stop, right? Now, input, tell you input, that means you get my number from the end user. So what happened with this step here? Actually, understand that for input here, you have the slot with the memory in the memory with the name here, my number here. My number here. Now you got input, he entered number 5. So what happened? My answer here, right? You have another slot in the memory, and the name of the slot here, it is my answer here. Right? And what happened? It take it down my number. It reference to the memory in the memory with the name my number. I take it down number 5 times 2. It put the number 10 here. And so let's on output. So print it out, take it out, and print it on the screen number 10. That's the process of this program here. Now think about this one here. Remember about the pseudocode. It's very everything is quite the same with the following format. You have a start, stop. Every program normally you have the 2 major components. Right? You need to get the input, you do the processing, and you put the output. Okay. Now this is the pseudocode for the flowchart here. For the the flowchart. Flowchart it also it is pictorial. It's very straightforward to see it here. You have to create a flowchart. You can draw geometric shape that contain individual statement, connect shape with arrow. Right? And you have the input symbol, you have processing symbol, and also you have the output symbol. And so and everything they interconnect them together by the arrow here. And later on, you can see that is flowchart here. That flowchart. This is flowchart. You have start, stop here. Start, stop. You can think about this one is pseudocode. Start, stop here. Now you got the input from user. The same is this one. Input from user. You have the my answer equal to the my number times 2. The same this one. Same this one. And the output here. And you have output here. Now this is a flowchart. This is a pseudocode, and this one I work with the Raptor. You can think about the Raptor. It's quite similar to the flowchart. You see, you have to get number, my answer, and put it out. Now open the Raptor, and I can show you how to work with this very simple program here. Open the Raptor. The first thing you can see, I can show you with the Raptor here. So basically, for the Raptor, when you open the Raptor, here's the interface. Here's the interface Raptor. Yeah. So here's the interface Raptor. So see in the Raptor on the left, you have the symbol here, right? You have the input and output here, and assignment here, right? So the most basic one is that the first thing here for this program. For the first program, you need to get input it, and when you get input, you double click it. Save it. You have to save. That's it. Okay. So for this one, when you double click it, this is the input. You see, I drag and drop input here. Double click it. I store into the. I have no problem here. For this one, I said no problem. I later on explain what is the problem later. But I want to store into the variable name my number here, right? So I put the my number here. My number. Right? Now the second one is processing. Every processing you work with the assignment here. So you just drag and let me put in the 150 here so we can see. Now everything about processing you work with assignment. So for this assignment, I want to assign the new one is my answer, right? I assign my answer to the my number. You will have my number here, right? Subject, you have the subjection here. Time 2. That is processing. And then later on, the output, I just want to take it out. What is my answer? Answer, I just read it out once. Okay, that is very simple program. Now, you can do the same. You can do the same with me. So, no. See, when I'm explaining later on, okay, let me do it again. Let me do it again and again. Now, see, the first thing you got the input, right? You drag it out. Now, when you double click the input, the prompt, later on, I explain the prompt. Prompt is everything about tell you what you expect to. So think about this one here. For me, right now, I don't have any prompt, so I just put it double quote mark here. Two double combine. I don't know how to put prompt. But you see, you have the variable here. That is where you put the name of variable. Right? And you can see the variable here, I want to put the name of my number here. Alright. Okay, you can do the same. You can follow what I said. My number. That is a step you get it from user. And you store it into the my number slot it. Alright. Now the second one is the processing. Processing is the assignment here. You drag and drop the assignment. And again, you double click the assignment here. Now, I want to get the value from the my number. And I want to double it. And the new value I put it, I want to store it into the my answer. So there's the step here. See, I want to take it from my number, double it, and I set it to my answer. It's a new value. And done it. And later on, the last thing, I want to take it out. What is my answer here? What is my answer here? And I just put it out. It's a variable name, my answer. Sorry. Answer. Yes, I just want to take it out. You put it. But oh, this one is my answer, not my own. Okay, let's see. The view, whatever. Now we will need so that is where you get it from the user, right? Now you do everything with the processing. Processing here. One, pick it out. Yeah, there goes the price. Okay. So when you're done this program, again, this one very simple program. And remember that you have the three major components: input, right? Processing, and the output here. Now, to run the program, you have the multiple ways to do it. The first thing, you can click it here. You can where my mouse? Okay. Yeah, you can click on this one. You run. So this one here, I enter the number 10, right? And enter number 10. So we see what happened. It stores the number 10 it stores the number 10 into the variable name, my number, right? And after that, you see, my answer here is assigned to my number. Take it out number 10 here. Time it to 2. That's why I have the number 20 here, right? And print out number 20. And you can see in my output here, it printed out number 20 here. Right? Make sense? And again, you can run it again. This time you will enter the number 5. And the double it, we have number 10. So you see, that is a variable. It's changeable. One time I can have number 10, the next time I can have number 5, whatever it is. So that is the one way you can run it. You can run it here. That is the one way you can run it. Let's see the value here. I enter the number 15. Done. Okay. Now that is a one way to run it. But for complicated program, if you want to run it step by step, you are able to do it and can see what is going wrong with the program, right? So if you want to run step by step here, you click on this one. Click on this one. You start here. Now get my number. Enter the number 8 here. And click done. Now we want to run it. See what happened here. After this step, I have the number, my number. I got the value 8 here. Right? And now I can run step by step. I click one more. See what happened here. Now see, after this step, my answer is my number times 2. That's why I have the 16 here. And the last step, I just take it out and print it out number 16. Okay? Okay, so basically this one is very simple program. You can click it run here. But when you have something wrong with program, in the syntax error or logical error, you want to run step by step, you click on this one here. Run step by step. Make sense? Okay. Now, I'm talking about from now. If you look on this program, here, when you run it again, I run it again. Right? You see, when you run it again for this program, if you look on this one, from end user point of view, I have no idea what's going on, what I'm expected to do here. Right? So better that you put it from here, tell user what he should do with the program here, right? So I can modify my program here. I stop here, and I can go back to this one. I modify this one. Please enter the number. Okay, so we can see. Remember one thing there. The prompt is only have meaningful to the end user. It have nothing to do with the program here. So basically, when you execute it, it have no value with the program. But from end user, it tell you what you have to do here, right? So see, if I send it here now. Now what I have to do here? I run it again, and you look on this one here. It tell me, please enter a number. It's way better for end user, right? That program expect that you have to enter it instead of A, B, C or whatever, right? So that is the meaning of prompt. Prompt that it tell user what he has expect to do with this one here, right? So again, I put the number 10 here. Let's see what happened here. Print down number 20. It print down number 20 is the correct one, but the only number here is not make really sense, right? So I can modify it again. I can modify my output here and can concatenate it with the check here and here. And this, remember this one is variable, right? So I put here number double number. Okay, so what happened with this one? I have the text here. The number after double it, that is the text. So when you run it, it literally print it out exactly the text. What is it, right? Whatever you put in the text, it print out exactly the same. And this is a variable. That is variable here. So it depends on the value of variable. Sometimes it can be 10, sometimes it can be 20, and so on. Right? So see, I run it step by step. You can see what happened in my program. I run it here, right? step by step. Now you see, I have input. In the input, tell me please enter a number. Right? So I put number 15 here. Now I got the 30 for my number and I print it out. Here, the number after the double is 30. Make sense? Okay, so in your program, always try to integrate the prompt here. It really helpful for the end user, right? To see what is going on. See, for this one, please enter the number, right? And for this one, number after double is 30. Make way more sense for the end user if you integrate the prompt here, right? The same this one also. If I modify it into the my program here, I do not have the prompt. I do not have the prompt here in the Python. I will see what happened. Still run. Yeah. Right. Now see, if I run this program in the Python, what happened here? Run. But you see, I have no idea what I expect to do here. I don't see anything here. Of course, for this one, I know that I have number here, and I print it out. Run it again. I don't know what I have to do with this one. If I am end user, I don't know what I have to do here. Even though that I enter the number 10 here, work perfectly, but should be better put some from here, please. And this one also, I can print it here. Right? The number after double is okay. It way better for the end user. See, run it here. Now please enter number. Again, way better. Then number 10. See, the number after the double is the 10. Now you see, the output is totally different here. The output always set, right? You see, it's different. Now, before is print out 10 and 20, right? But after that, please enter the number 10. Number after the double 30, right? It makes way sense to the end user. So for every program, try to integrate meaningful prompt into the program. You think about if you are the end user, you need to know what is going on in the program, right? And what you expect to do with the program. Make sense? Any question? Okay. So come back to my slide here. Let's see. I want to highlight here. I want to highlight what's this one here. This program, I don't have anything with the prompt. That's why I see when I execute here. When I execute from end user point of view, I have no idea what I have to do. Right? So, but you see, if I put the from here, from the pseudocode here, right? Enter a number, tell the user the enter number, right? And store it into my number. And again, in the output here, my answer is type it down, right? The same with this one also. Now enter a number, my answer is. Make sense? Okay, so again, from now on, I expect you when you do with any program with Rudder or Python, try to integrate meaningful prompt to the end user. And it isn't think you are the end user. And you need to think about this. Now, one thing about okay, I can. Okay, so you see, you can draw the flow chart with the flow chart or the pseudocode, right? Or the other the same, right? But always try to integrate the prompt here. I think that's all for today. It's quite a lot of information. So I'll see you on Wednesday. But before we end the class, I just want you to go over all of the slide I have on the class today, and you can go ahead with the slide at the end of the module and invite me on Wednesday. Right, but if you have any question or anything that's challenging for you, just let me know. So on Wednesday, we'll go on with the lecture with the slides here, and I will help you to work with some of the assignment, homework assignment, right? Because the first week I know that some of you very totally really strange view, like not really familiar with the structure of the homework here. So I want to help you with some of the assignment on the first week. See what you are expect to do with the assignment. Okay, you almost done with the slide, and I think when on Wednesday you go with the remaining slide and you go with the some of the assignment on Wednesday. Okay, any question or any recommendation? No. Okay, so I see you guys on Wednesday. Okay. For the guys online, do you have any question? Grant or Jeremy, do you have any question?
I don't think so. No, not right now.
Okay. Okay, so I see you guys on Wednesday. Bye bye.
All right. See ya.
All right, see you.